Okay, the last question for the day. So in this video, there are two goals. The first goal is to find the solution for this problem, and we are going to do some coding on top of it. And the other goal is to see how we should behave in a real interview. So let's get started. So remember, the first step in a real interview is to always try to understand the question. If there is anything unclear, please bring up the question to the interviewer to clarify, and also at the same time think about the edge cases. So let's see, word break 2. So given a non-empty string s and the dictionary word dict containing a list of the non-empty words, add spaces in s to construct a sentence where each word is a valid dictionary word. Return all such possible sentences. So the same word in the dictionary may be reused multiple times in the segmentation, and you may assume the dictionary doesn't contain duplicate words. And let's see the example. So input is this, and word dict containing all of those words, and we have cats and dogs, and cats and dogs as two different options to decompose the original input string. So yeah, so that's pretty much it about this question. So regarding the edge case, I would say if the word dict doesn't contain any word, then it potentially could be a edge case. But other than that, I think we are fine because it says the input string is gonna be non-empty. Alright, so the next step is about finding a solution. So for finding a solution part, so this one, it's more of a enumeration of all the possibility of the decomposition way. So essentially, we are going to enumerate all the possibility. So for the worst case, it could be that we have a lot of the words in the dictionary, and we end up chopping the original input string in a lot of ways. So for example, for each position, we could choose either to chop it, or we could choose to have it connected to the next character to combine to a new word. So yeah, it depends. It really depends on the size of the dictionary. So in this way, the worst case would be 2 to the power of n. There are 2 to the power of n options, and for each option we are going to go through the string. Thus it is going to make n times 2 to the power of n. So if you argue that we could store, so maybe there are some potential optimization. So for example, you could store all the possible ways to decompose some substring to remember. Okay, it's like we decompose this into some subproblem, and memorize the status. It's like dynamic programming, and then reuse the result later on. That could potentially be a bit better, but it really depends, because what I can see is that there are a lot of the copy paste of the strings from the DP array. So let's first try to implement the first solution, which is kind of like decompose the original string into enumerate all the possible ways to chop the string into words that are contained in the word dict. So let's try to do some coding work. So first of all, we see the edge case as if the word dict dot is empty. So if this is empty, then we are going to return. So let's say AR, so list string. Let's say word breaks is equal new linked list. Return word breaks. Yeah, so that's it. And also, if it's not empty, then first of all we need to try to turn the word dict into a set. So we will define a helper function. Let's say private set of the string as list to a set. Okay, the string, this is list words. So set string set is equal to new hash set. So string word is going to go through the words and add it into the set. And then finally we are going to return set. Okay, so now we have the set of the words. Let's say we call it dict as list to set called word dict. So then we should be able to call. Okay, so let's see. So first of all, I will need to define a word array, which is something like this. To store the words we have decomposed into. So let's say new string as the length. Yeah. So now it's time for us to define the helper function, which is the recursion with backtracking. So I'll say, let's just overload this function. Let's say word break on top of s and the index of it, and also word array and the array index, and also the final results we are going to return, and finally we are going to return word breaks. So this is a helper function we are going to define. So let's say we define void word break. So yeah, so string s idx string words, and say widx, and let's say this is the word breaks. So if idx is as length, so remember for recursion always to try to implement the exit of it at the beginning, which would be a good way. So for this one, we say we are going to try to turn the word array into a string. So I will say to string words to a string. So we are going to pass the words and comments. So we are going to implement this later on. So here, if it is equal, then we are going to say word breaks dot add words to a string. This is words and idx. So we are going to return it. And yeah, so, and yes, that's the exit. And how to go on. So we are going to say, alright, so in I is equal to idx plus 1, I smaller equal to s length plus I. So string word is equal to substring idx to I. So if the not, alright, so we also need to pass in the dictionary into it. So we are going to have this one as a set of the string as the dict. So if the dictionary doesn't have the word, then you simply continue. Otherwise, if it contains a word, then we are going to say, alright, so word break, call word break s on top of idx. This is actually I, okay, and words and w idx plus 1, and then the dict and the word breaks. Now of course we need to have the words w idx as equal to word. So we set the current word as word, and then we are going to further call this recursion. So as on top of I, yeah, so I think it should be correct. Let's then implement the words to string. So we are gonna say, okay, define the string builder. So int I is equal to 0, I is smaller than count minus 1 plus I. So sp dot append words I, and sp dot append a spice in it, and finally I'm going to append the last word. So words just count minus 1. Alright, so then we are going to return sp dot to a string. So far I think we have implemented the body of the each function, all the helper functions. So we are not done. Let's do some testing on top of it. So we need to go through a test case to explain how this piece of code is going to work, but to be short, I'm not going to go through the full example. So let's say we are going to use this example input as this and word has this one. First of all, we are going to try to turn the list into a set, and then the word is going, we initialize the word array and then send it to the word break function. So within the function, if it is an exit, then we are going to put all the word together into a string and this add it into word breaks, which is the final thing we are going to return. So let's see. First of all, we try C is not a dictionary. The word in dictionary C is not either, so we skip. We continue. So cat is a word in the dictionary. So we are going to set word 0 as cat, and then we are going to do the rest of the job. So I would say this seems to be right. Let's give it a shot to see the correctness of it. Alright, so it says word, so incompatible type string cannot be converted to a int. So yeah, so I think there's a typo here. So yeah, so this is accepted, but believe me or not, so I have submitted this this version of the code and it got time limit exceeded. So what I did after that, I did some optimization on top of it. So what I did is I introduced a Boolean array called let's call it DP array. So essentially what it does is it is used to record like starting from index I, let's say starting from this index, whether the rest of the rest of the string, like starting from the index, whether the rest of the string can be decomposed into a set of words contained in word dict. So we will have another thing. Let's call it dp as new. So essentially the worst case runtime is not gonna be better, but it's just we are just going to cut some branches using this technique. Like cutting branch is a pretty common technique yeah, it's a pretty common technique in the backtracking with recursion. So let's say this one, we initialize the DP thing, and we first of all set everything to be true. I is equal to 0, I smaller than vt.length plus I plus 1, or just smaller equal to this, and then plus I. And finally, actually we just need this. We don't need to have more than the length of the string, so we just need to return what else? Yeah, I was so this one is set as true, and then we pass the dp array into it. So here we will set the boring, let's say dp here, and as I said, so the dp idx indicate whether you can decompose the rest of the substring into a set of the words in the word dict. So let's say if not dp idx, then we are simply going to just return. And how are we going to set this dp? So we have used it, but how are we going to set it? So we are going to set it at this one. So original size as equal to word breaks size, and if origin size is, so if origin size is equal to word breaks size, then we are just going to set dpi as false. Alright, so essentially it is saying, so by this function we are trying to decompose the substring starting from I into words containing word breaks. So if this one, so if after calling this function, the original size of the word break is equal to what is after we call this function, then it means we cannot really decompose the substring into the word, into a set of the words containing contained in the dictionary. So in this case we set dpi as false. Yeah, so let's run it again. Alright, so it has some typo where it is 72. Alright, missed a column here, so word break, yeah, so we need to call it, send dp here as well. Yeah, so after that, when I do a submission, it is accepted. So in this way, actually, we could, yeah, so it's more like a branch cutting, cutting some branches that are useless. So there could be some other ways to solve this problem. So for example, we could remember the ways we cut the rest of the string, like the suffix, and then we just simply reuse it when we need to decompose the same suffix next time. But the thing is, we need to copy paste the strings a lot of the times, so it is, so to me I think that it is pretty expensive to do this like copy paste. But it depends. So yeah, it really depends, and it is more of a trade-off about the space and time. So if I would say it depends in the interview. So it depends in the interview. I think if you in the interview, if you can implement this and also do some certain optimization within 45 minutes, I think it should be good for an interview. But you can also you can also say that there could be other ways to optimize it, like doing some memorization about the options, how to decompose the substring, and try to utilize the result later on. If the interviewer asks you to implement that, you can go ahead and do it. But if you don't have enough time, so I think that should be okay if you leave it as it is. So that's it for this coding question. If you have any question about this coding puzzle, please leave some comments below. If you find this video pretty helpful, please give me a thumb up and help subscribe to this channel. And I'll see you next time. Thanks for watching.